Okay, so now we actually get to practice. Let's go to example 1. Use the calculator to find the value of each expression, round to 2 decimal places. Notice how the calculator, or the instruction I meant, did not tell you whether your calculator should be in radians or degrees. So in that case, I always, repeating myself, always want you to be in radian mode if it doesn't say otherwise. Now, if it says change your calculator to degrees, then you put it in degrees, or you see a bubble, a degree symbol in the problem somewhere. If it doesn't, then I want you to put it in radian mode. Okay? So I can't show you my graphing calculator, so what I'm going to do is use Desmos. In your calculator, if you hit mode, you should be able to change from degrees to radians and vice versa. Okay, I don't have a graphing calculator on here, so I'm going to do Desmos. In Desmos, you should be able to hit this wrench right here, and you can go from degrees to radians easily. So we're going to be in radians. We want to do sine inverse, so I'm going to hit functions, sine inverse, and I believe it was negative 0.13. Now, as you can see, it happens to be the same answer if we round it to 2 decimal places. Now, not always the case, so don't just assume it's exactly the same. So final answer, negative 0.13 or negative 0.13. So we're back to B. Cosine inverse of a positive 1/8. So Desmos, I'm going to hit functions, cosine inverse 1 divided by 8. So that gives us a 1.45. So 1.45. Okay. Now you're on C, tangent inverse of a square root of 3 divided by 5. I'm going to ask you to do that on your own. Now don't forget to enter it in the play pause it as well as write it in your notes. Example 2, find the exact value. So the exact value meaning that you may not use a calculator, so no calculator of any type. So go ahead and put your calculator away. This is where if you know your unit circle really, really well, it helps you out. So for example, if I said, okay, sine of 30 degrees, it's what? Then you spit out sine of 30 degrees is 1/2. Well, now we're going backwards. Sine inverse of 1/2, you should be able to give me 30 degrees, aka in radians. So that's going to be pi over 6. Okay. So let's do A. Sine inverse. So again, if we're starting at an inverse function, we have to know restrictions, right? The restriction for sine inverse is going to be 0 to pi over 2 inclusive, and negative pi over 2 to 0. So negative pi over 2 to 0 and pi over 2. So we cannot, again, we can only have answers in 1 and quad 4. We cannot have any answer in quad 2 and 3. So let's just pretend that you don't know the answer to A. So sine inverse of 1 equal to some unknown answer. And this answer's got to be radians, right? And radians is a type of angle. So what I'm asking you to do is, okay, well, what if you go and compose both sides by sine? Okay, so what we're doing is go in and compose the left side by sine. That means you are going to compose the right side by sine as well, because what you do to one side, you do to the other. So now sine and sine inverse will cancel each other out. So now you have sine of some angle equal to 1. Now, if this helps you find that some angle, then this is what you can do. But you should be able to know that, okay, sine of pi over 2 is really 1. So theta is really pi over 2. So your final answer is pi over 2. Okay. Now on B, if you know the unit circle really well, sine inverse of 1/2 should be 30 degrees, but in radians is going to be pi over 6. So, well, is there another way if I don't know the unit circle yet? Okay, if you're saying yet, please go and study the unit circle now. So, same thing. We know the answer is going to have to be in some sort of an angle. Let's give it a radiant. I'm sorry, theta as a sample or a variable I meant, of our angle. Then compose both sides with sine. So what you do to the left, you're going to do to the right. Now all you're doing is just kind of rewriting it in this way so you can recognize what theta should be. So when you rewrite it this way, you're going to realize that, okay, well that theta is 30 degrees, aka pi over 6. Oh, that's a funky looking 6. Okay. Now on letter C, it's slightly different. Cosine inverse is restricted from 0 to pi. So quads 1 and 2. Now this is a negative ratio of a rad 2 over 2. So you know your answer must come from quad 2, because in quad 2 that's when x is negative. So let's just pretend that we don't know what that answer is. If you know the answer, even better, just write it down and move on to the next question. Then compose both sides by cosine. Okay, so what's happening is cosine and cosine inverse is going to cancel each other out. This is allowing you to think cosine of what in quad 2 is negative rad 2 over 2. So that's going to help you identify that this angle must be 3 pi over 4. No, you cannot give me 5 pi over 4, and no, you cannot give me 7 pi over 4, because cosine inverse can only be in quad 1 and 2. Now what happens if you give me pi over 4? Then that's going to give me a positive rad 2 over 2, and that would be incorrect. So it can only, that's why for inverses, that's why it's restricted to 2 quads. One of it's going to give you a positive ratio, and one of it's going to give you a negative ratio. Okay. Letter D, if you know the answer already, go ahead and fill that in. Okay. And if you don't, let's think about it. Cosine inverse again, restricted to quads 1 and 2. So now we're going to say, okay, well, cosine of what angle, right? In between 0 and pi, it's going to give me 0. Well, cosine of 0 radians, that's 1. Cosine of pi radians, that's going to be negative 1. So my final answer is just going to be pi over 2. And how do we know that? From the unit circle. Tangent inverse restricted in quads 1 and 4. It's a positive ratio of rad 3 over 3. So now, you know the answer, you write it down. You don't know the answer, then please listen on. Now, if you were to compose both sides by tangent like this, then it will help us think it the old school way. Okay, cancel, cancel. So now all you have is tangent of what theta is rad 3 over 3. Now, if you want to undo the radical, I mean unrationalize, that's going to be 1 over rad 3, if that helps you think further. Tangent some angle has an opposite leg of 1 and an adjacent leg of rad 3. That can only be pi over 6. There you go. All right, and now pi over 6 is in quad 1, and that should correlate to a positive ratio. All right, last one on this example. I love tangent inverse of 1 because number 1 is restricted to quad 1 and 4. 1, it's a positive ratio of 1 over 1, so the answer has to come from quad 1, right? And tangent of pi over 4 is the only angle that will give you 1. Let's go on to the next example here, example 3. Find the exact value. If there's no value, say it is not defined. And again, exact value means calc or non-calc? No calculator, okay? Now, we are still going to use PEMDAS. So first things first, we're going to try to see if we can do the inside of the parentheses. As you can see, inside of the parentheses, it's a regular trig function, sine of pi over 8. Regular trig functions do not have restriction. So class, That angle inside could be anywhere it wants to be, okay? So currently pi over 6 is pretty small. It's obviously smaller than a pi over 6. I'm sorry, pi over 8 is smaller than pi over 6. So if pi over 6 is right here, pi over 8 is somewhere over here. Like that. We're just doing an example. Would you agree that's in quad 1? Well, because pi over 8 is in quad 1, sine and sine inverse could cancel, and here's why. Sine inverse is the outer component, and outer component is sine inverse, meaning it's restricted in quads 1 and 4. Since pi over 8 is in the restriction, then you can, I'm repeating, then you can cancel out its regular and its inverse to give you your angle. Okay, so final answer is pi over 8. Now, B is slightly different. B has cosine inverse inside. So what's that's going to be like? That means whatever the inside is, it's going to give you an angle. But how would you know what the angle is if you don't have a calculator? Because you don't know 0.2 without a calculator, right? You know a half, you know rad 3 over 2, you know for tangent, rad 3 over 3, you know rad 3, but a 0.2 is not right now possible without a calculator, but that's okay. So first we will execute inside for the parentheses. It's an inverse, so it has restriction. It's restricted to 1 and 2. Oh, I just did the 2 and 1, but that's okay. You know what I mean. It's a positive number. 0.2 is a positive ratio. So we know this angle will come from quadrant number 1. Okay. Now I want to bring something up to you as well. I'm going to write our inverse function. Y equals cosine inverse of x. Would you agree that this is 0.2? It's an x value. Okay, so back in the days, we were stating the domain and range of the inverse function, and this is why it's important, okay? So domain of an inverse is the range of the regular. In this case, is -1 and 1. The range of the inverse was where we cut it off, so that was from inclusive 0 to pi. Okay, so 0 to pi, unit circle. Now, I want you to relate this. The 0.2 is the input of the cosine inverse function, which is the domain of the inverse. Would you agree that 0.2 is in the domain? So what that means is because it is in the domain class, you can cancel cosine and cosine inverse. So this will give you a 0.2 as the answer. Now, we can also go back to part A to do the same thing. I'm going to write y equals sine inverse of x. Okay, the domain, sine inverse, -1 to 1 inclusive, the range inclusive, -pi over 2 to pi over 2. Well, this angle right here, class, pi over 8 is not the domain. Okay, I want you to be very careful. It's not the domain of the inverse. It is in the range of the inverse. So pi over 8, it is in between -pi over 2 and pi over 2. Therefore, it allows you to cancel. Okay. Now let's go to cosine inverse of cosine to 5 pi over 6. And this C will also relate back to A if you didn't understand part A. So 5 pi over 6, you know how to do it. So what if I do it old school, right? Just find cosine of 5 pi over 6. Actually, why don't you do that for me? Take a second to find the exact value of cosine of 5 pi over 6. Okay. If you said negative rad 3 over 2, then you are correct. And the reason it's negative is 5 pi over 6, it's in quad 2. In quad 2, it will give you a negative ratio. Now, but I'm not done. That's just the inner component. So now I'm going to do cosine inverse of negative rad 3 over 2. That's my next outer component. Okay. Cosine inverse, we now have to think about restriction versus cosine 5 pi over 6. That's not an inverse. We don't think about restriction, right? It's restriction 1 and 2. Well, it's a negative ratio, so we know it has to come from quad 2. Well, guess what? I'm already in quad 2 from 5 pi over 6. So cancel, cancel, 5 pi over 6. Okay, so now let's go back to doing the same thing we did for part A to see if that will allow you to connect the two. Y equals cosine inverse of x, domain, -1 and 1, range, 0 to pi, okay? Now earlier in part A, remember I talked to you about pi over 8 is the range, and this is why. 5 pi over 6 in C is the range of the outer component. So since 5 pi over 6, it is in between 0 and pi. That's why you are allowed to cancel out the cosine inverse and cosine. Okay? Versus in B, cosine inverse is on the inside. So that value is a ratio, and a ratio is a domain. A and C, cosine inverse is on the outside. So the angle represents your range. So that's what you want to compare in, okay? And the more you practice, the more you're going to get better. Letter D. Okay, this one's really difficult, so I need you to pay attention and rewind if you need to. And I'm going to go slow. Tangent is 7 pi over 5. It's not one of the angles you know, but that's okay. We can still do it without a calculator. So this is 0 or 2 pi, this is pi over 2, this is pi, and this 3 pi over 2. But the problem is you have a denominator of 5. So I'm going to try to convert everything into a denominator of 5. Okay, so for pi, that's easy, that's 5 pi over 5. Okay, now pi over 2, I'm going to do 2.5 pi. Okay, that will give me half. Now over here on the denominator, 3 pi over 2, I'm going to do, think about it, I'm just going to add this and this together. So that's 7.5 pi. Okay. So you are given 7 pi over 5. That means that angle, it's in quadrant number 3. Okay. It's pretty close to 7 pi over 5. Okay. Are you with me so far? So 7 pi over 5 is all the way here, okay? Next, it's in quad 3. So quad 3, if you look at the outer component, it's tangent inverse. And tangent inverse can only be in quad 1 and quad 4. Oh no. Does that mean there's no answer? That's not true. Because tangent of 7 pi over 5 is on the inner component, you will always have an answer, okay? And let's think about it really quickly. I'm going to take it to a level or an angle that you do know. Let's say pi over 4. Not pi over 4, 7, 5 pi over 4. So would you agree, any angle in quad 3 for tangent, I will be able to get the same exact answer in quad number 1, because in tangent in quad 1 and 4, they are exactly the same. Same concept with 7 pi over 5. So what I'm going to do is I'm going to find out this reference angle, okay? Remember, this whole angle is 7 pi over 5, and this right here is already pi. So this reference angle class is going to be 2 pi over 5. That means, I'm gonna try to find a different color here in green. Okay, now pay attention. That means in quad 3, tangent should be able to find an equivalent angle in quad 1. Also 2 pi over 5. Remember, these reference angles got to be the same. So erasing the known angle here. Give me a second to erase. I need more space. I'm explaining a lot because this question is by far the most difficult. So tangent of 7 pi over 5 is identical to tangent of 2 pi over 5. Okay. So what that means is we are about to do tangent inverse. 5 pi over 5 is not acceptable. It's out of the restriction of tangent inverse. So we are going to do the equivalency. Tangent inverse of tangent 2 pi over 5. Now, this allows the cancel. So final answer is 2 pi over 5. Okay? All right. I need you to pause it, soak it all in, rewind if you need to. Okay, so when you think you understood, we're going to move on to, whoa, that's too much. Sorry, I'm trying to move and it's being super sensitive. Okay, there you go. E and F. Okay, so that is different from E and F. E and F are related, but different from D. Okay. First, we're going to do the inner component, cosine inverse of 2. Well, let's talk about that function again. It's an inverse function. Domain is inclusive from 1 to 1. Range is inclusive 0 to pi. Well, Houston, we have a problem. This 2 represents the input of cosine inverse, which is going to be compared with the domain of the inverse. Notice how I keep saying the inverse. Well, 2 is outside of that domain. Therefore, this class has no answer. So you can say undefined. Undefined. Or in the instruction, it said no value. I will take any one of those, okay? All right, I will pick whatever you write as long as it's saying undefined, no value, or the 0 with a cross through. Now this is very similar to this one. Again, we are going to attack sine inverse of 1.9. So y equals sine inverse of 1.9. The domain of sine inverse is from -1 to 1. The range is from -pi over 2 to +pi over 2. All right, let's check this out. This 1.9 is an x value, which is comparing to the domain. Again, it's outside of the domain of sine inverse. Therefore, you do not have an answer. It is undefined, no solution. However you want to write that answer. And that's all of example 3. Example 4, find the inverse function, which is f inverse of each function f. Find the range of f in the domain and range of f inverse. Okay, so part A, f of x equals 3 cosine of x plus 1. This right here is restriction for x, which means it's the domain of f. That's why in the instruction it says only find the range of f. So because the domain's already provided for us. So to find the inverse, we will switch x and y for x. So this is f of x, which is the same as y. We will go then make it x equals 3 cosine of y plus 1. Then solve for y. Move 1 to both sides. So x minus 1 equals 3 cosine of y. Get rid of the 1/3 by multiplying the whole thing by 1/3, or you can even divide everything by 3. It doesn't really matter to me. So this is 1/3 times x minus 1 equals cosine of y. You can easily distribute that. Now if you divide everything by 3, it would look like this. Okay, now we have to solve for y, meaning that we have to go in and compose this by cosine inverse. What you do to one side, you do it to the other side. So now cosine and cosine inverse will cancel each other out. So you can end up with the y equals cosine inverse of x minus 1 divided by 3. Or you can easily have had cosine inverse of 1/3 times x minus 1, or you could have distribute the 1/3 out. Not important to me. At this level of mathematics, you guys are pretty good with algebra. Now we have to answer a couple questions. It says here, find the range of f? Well, the range of all cosine, parent cosine, okay? So if I just give you this, y equals cosine of x, the range is from -1 to 1. Now, but if I give you y equals 3 cosine of x, that is now the amplitude of 3. That means the amplitude, you guys remember, what is the height from the center? So now you go up 3 and then down 3. So the range is really from -3 to 3. But your f function is really 3 times cosine of x plus 1. The additional 1 on the end right there is a vertical shift up 1 unit. So if you shift up 1 unit, what are you really doing? You're adding 1 to the y's. If you add 1 to the y's, then your range is now really -2 all the way to 4. So the range of f is -2 to 4. Now, the domain and range of f inverse is super easy, okay? Domain of f inverse, range of f inverse. All you got to do is you go find the domain and range of the regular and switch them. So the domain of f inverse is the range of regular, which is from -2 to 4. And the range of f inverse is the domain of the regular, which was already given to us, 0 to pi. And highlight or box all of those up. There you go. Part B. Given to us, f of x equals 2 tangent of x take away 3. And they gave us a restriction from -pi/2 all the way to pi/2, which is the domain of f. So now, let's switch x for y and y for x, and then solve for y. First things first, add 3 to both sides. So now you have x plus 3 equals 2 times tangent of y. Divide both sides by 2. So now you're going to have x plus 3 all over 2 equals tangent of y. Compose both sides with tangent inverse. Tangent inverse. So now you have y equals, which is really f inverse of x equals tangent inverse quantity x plus 3 all over 2. That is the inverse function. Box that up. Now we have to find the domain of tangent, okay, because the range of tangent, because the domain's already given. This is the domain. Remember, the graph of tangent goes up and down forever, so the range of f is going to be all real numbers. You can write from -infinity to infinity. That leads me to the domain of f inverse, which is going to be easy since we have already found or given the domain and range of regular. So the domain of f inverse is the range of regular, which is all reals. The range of f inverse, which is the domain of the regular, which was provided for us, -pi/2 all the way to pi/2, non-inclusive. Box that up. Now, you're on example C. They are giving you f of x equals 3 sine of 2x and giving you the domain from -pi/4 all the way to pi/4 inclusive. So switch x for y and y for x and solve. So first, divide both sides by 3. So x divided by 3 equals sine of 2y. And no, you are not going to divide by 2. You have to compose sine inverse first. So now this is going to look like sine inverse of 1/3 x, or x divided by 3, equals 2y. Now we are going to get rid of the 2 by multiplying by 1/2 here. And I'm going to put that 1/2 in the front. So finally, y equals, which is f inverse of x, equals 1/2 times sine inverse of 1/3 x, or x divided by 3. I'm just going to write 1/3 x this time. And no, it does not matter if you write x divided by 3. That's the inverse function. So it wants us to find the range of f. Okay. Now, if I give you y equals sine of x the range is going to be from -1 to 1. If I give you y equals 3 times sine of x, that's an amplitude of 3, so it's really -3 to 3, or you can even think of it as a vertical stretch factor of 3. So you're going to take your original range and you multiply by 3, so that's why it's -3 to 3. Now, what if I give you y equals the sine of 2x? If the 2 is inside, does it really change your y value? It does not, right? Because this is really a horizontal compression factor of a half. That's really changing the x's by a half. That's why your domain restriction is now half its original restriction. The sine inverse usually has a restriction from -π/2 to π/2. It's horizontally compressed by half, so that's why it's now from -π/4 to π/4. So even with this 2 right here, it doesn't change anything. So your range of f is just really from -3 to 3. So now we can go and write domain of f inverse, range of f inverse, and all we got to do is switch what we have. Domain is -3 to 3, and range of inverse is -π/4 to π/4. Either box it up or highlight it up, and voila. We're now on example numero 5. Find the exact solution of each. Well, again, anytime you see the exact, meaning no calculator. As you can see, these all starts out with an inverse function here. That means it has restrictions right away. So make sure you're very mindful of that, okay? And you solve it regularly, except that you need to be mindful of the restriction. To get rid of the 2, you multiply 1/2 to both sides. So now you are with cosine inverse of x equals π/4. To solve for x, we will compose both sides with regular cos. And then cancel, cancel. X comes out to cosine of π/4. Well, what on earth is cosine of π/4? Didn't I tell you how important the unit circle is? Super important. So cosine of π/4, it's just √2/2. Now we got to check though, okay? Is this right here in quad 1 and 2? Sure it is. That's in quad 1, so we're good. We could get an answer. Letter B, divide both sides by -4 or multiply both sides by a -1/4. It's really up to you. So now we have tangent inverse of x equals -π/4. Compose both sides by a regular tangent. Okay. Then now we have x equals tangent of -π/4. Okay, so let's check this really quick. This -π/4, is that within the restriction of tangent inverse? Yes, it is, because tangent inverse is in quad 1 and 4, and -π/4 is in quad 4, so we're good. We can go on and find the answer. Now, because you know your unit circle really, really well, tangent of a -π/4, it's actually -1. So final answer is x equals to -1. Letter C looks extremely scary, but it really isn't. Okay? All you got to do is combine like terms. Yes, you can totally combine inverse functions. No big deal there. At the same time, I'm going to add 2 pi's here to the right. Okay, bam. Okay, so 5 sine inverse of x, take away 2 sine inverse of x, I will end up with 3 sine inverse of x. And -3 pi plus 2 pi, I'm going to end up with a -pi. So far, so good. Divide both sides by 3. Sine inverse of x equals -π/3. Compose both sides with a sine. And check to see if -π/3 is in the restriction for sine, and it is because it's in quad 4, and sine inverse can totally be in quad 1 and 4. So x equals sine of a -π/3. Well, sine of a -π/3, I need you to go ahead, bust out your unit circle or your memory and fill in that box. And guess what? This is the end of 7.1.